Okay, so this brings us then to our last of the three topic domains, which is computing. Mainly, the biggest portion of this is going to be the Unified Computing System, the UCS, which is mainly going to be managed by a web interface, which is the UCS Manager. This is where we're going to do things like define service profiles, which say like how many CPUs does my server need, what are the NIC cards, how much RAM is it allocated, things like you would normally do through like your vSphere management in VMware. But in this case, this is management for the physical chassis. The other big thing is going to be how do we integrate this with actually talking to the LAN and talking to the SAN. So again, when we look at our design here, and previously we had our servers that were attached separately with an Ethernet NIC card that's going to the LAN, and then we had a fiber channel HBA, the host bus adapter that was going to like your MDS switches. Now we have all of this collapsed down further. Okay, in the case of UCS, the physical virtualization, in addition to the actual like OS virtualization, like VMware or Xen, there's multiple levels of virtualization we need to talk about. So not only do we have our servers that now exist on physical blades in the chassis, which would correspond to like a VMware host machine, then inside of this we have our like VMware guest machine that's our actual like Windows or Linux server. But then on the backplane of the UCS chassis, we take basically the LAN and the SAN ports, and these run transparently inside the chassis basically as a converged network adapter.
And even if we didn't have VMware, we can present what used to be a physical converged network adapter on a physical server, a standalone server, and now we get to carve a single blade, a single piece of hardware up with a single converged network adapter, what was called a mezzanine card. It sits on the, just a raised platform on the actual blade, and now we get to carve up virtual NICs, virtual HBAs. So the idea of a server becomes completely abstracted from the traditional idea of a hardware blade or a hardware, I should maybe say a hardware rack mount server, right, where the idea of a server is really now something called a service profile, and we create pools of MAC addresses, pools of worldwide port names for storage, for fiber channel. We create, we assign those to virtual NICs, virtual HBAs, and we can carve up one physical server, not just with, and certainly for VMware or OpenStack or whatever we might want to put on it, but even just abstract that from a physical, if we were to do a bare metal install of an operating system and allow, assuming that we can do something called boot from SAN, where the disk isn't actually physically in the blade server and it's not what's actually carrying the operating system, but assuming it's out on a fiber channel array and zoning is set up properly and everything else, we can actually move a server over to another blade because all they are is an abstraction. They're a service profile and they're just pointers basically. So there's really a lot that we can do in the UCS and that they can test you on in the scope of the exam.
Right, right. So in addition to what I was saying here with the physical design of the chassis, we also have what is known as the UCS fabric interconnects. Basically, this is where our physical wiring is then going to be split out. So from the UCS chassis, we have uplinks where these are going to be 10 gig E ports that are going to multiple different fabric interconnects. For the case of redundancy, so if one of them goes down or we have a link cut, we don't have our servers cut off from the rest of the network. And basically, these two platforms are going to work hand in hand, where without the fabric interconnect, you literally cannot use the UCS chassis.
It's just a dumb
it's just a dumb chassis. So this is where the management is going to take place. This is where the UCS Manager, the UCSM, which is our web interface, this box is what we're going to be talking to here, the fabric interconnect. Then this is going to control things like when I actually have my allocations of servers, how do they relate from a virtualization point of view to the actual physical resources of the network? Because at the end of the day, we know that we have to physically put those bits on the wire, and they're going to be dealt with by physical cables. It's not, there has to be some end to the virtualization somehow. So we can get into really detailed designs where maybe I have blade A and blade B, and I say that the traffic for blade A must go this way to this direction of the network, and traffic from blade B can go this direction only, where this maybe is my primary and this is my secondary. So there's, again, a lot of details in the design that you can get into with this. So we need to understand first, what are the individual components? What's the overall design goal that we're trying to accomplish with this portion of the data center? And then ultimately, within the scope of the lab, is to tie all of this together. Where this is also going to come in with two other topics in computing, which is the virtual Nexus switch, the 1000V, and then the ACE load balancer, where the Nexus 1000V is going to run as a virtual machine. So on your UCS chassis, or on just your regular like bare metal server, like a 1U Dell server, you can take this, basically what is a VMware guest. So it's an NVMware machine. And this is a logical representation then of what would normally be like your physical Nexus 5K or your physical Nexus 7K.
Yeah, it looks like a CAT 6500 or a 7000 where I have a supervisor module and then multiple blades. So the supervisor module is this VMware guest or pair of VMware guests for redundancy. We always like redundant supervisors. And then the blades are something that we install into each ESX host, and they basically replace the vSwitch or distributed vSwitch. Right. And so it just looks like one chassis of a switch talking to the Nexus 2K or the Nexus 5K or wherever we have these interconnects.
Because figure, when we're dealing with the virtualization, one of the big challenges is how do we actually manage the network? Because the management previously, when everything was physical, was much simpler because I have a physical 1U server that has a physical link to a physical switch. I configure the switch, I configure the server, end of story.
What if I wanted to span a certain port? Or what if I wanted to insert a firewall?
Right.
It's very difficult to do that with all the virtualization.
Right.
The Nexus 1000 gives us that visibility again. Now I can span ports. I can remote span ports. I can plug an ACL in, or guaranteed QoS, or I can have even a virtual security appliance.
Right. So even though it runs in software on the actual chassis, it looks like a physical switch from our point of view from management, where we would have like Ethernet ports that are access ports that we would assign the access VLAN for the server, or we would assign, like Mark said, the QoS policy.
And we SSH into it just like a normal Nexus switch. It looks like a Nexus switch. It's just VMware. Instead of addressing it through the VMware version of vSwitch.
Then this brings us to the last portion of computing, which is the ACE load balancer, which ACE is basically an application level switch. If you're familiar with like F5 LTM, same exact thing, where the idea is that we have, maybe not the same exact thing.
ACE,
but
F5 actually gets used.
F5 doesn't use that.
Sorry to any Cisco people.
So basically the goal of the ACE module is this is where like my public IP would live. So let's say I have a web server, and my users are coming in from the internet. They need to talk to the web server. They're going to talk first, so they come in from IP. Okay, they come to the Nexus 7K. This is our layer 3 boundary. Okay, our division down here is going to be layer 2. So we now get down onto the layer 2 LAN. The Nexus then needs to know what's the MAC address of the server. So we know from traditional layer 2, layer 3 networking, we look at our resolution of the IP address to the MAC address with our address resolution protocol. That's what we're going to forward the frame to. Now normally, since this is a layer 2 LAN, the forwarding of the MAC address is going to go down here into the chassis, down to whatever the virtual MAC address is, like assigned to the virtual NIC of the server. But the problem then becomes is this chassis is so powerful, we don't want to run one web server. I want to run 100 instances of my web server, where I may have just one physical blade, but I'm running tons of virtual machines, because a lot of times your one physical bare metal box can't take all of the resources of the physical machine anymore. Because not only we're not running into limitations of like CPU utilization or memory utilization anymore, we're running into the application level problems where Apache can't address that much memory, or Apache can't spawn that many instances. So in a lot of cases we run into, or the design would better be solved to run multiple logical instances of the application and then use something at the front of it to mask this from the end users. And that's basically what the main goal, and obviously it has other features, but that's what the main goal of the ACE module is, that when the packets come in, they're going to go to basically the virtual address that the ACE is defining. Then ACE is going to do things like poll the individual servers to figure out what's the, is the server alive? So like if Apache crashes, but I'm able to ping the IP address, I want to know that. So doing basic layer 3 checking is not good enough anymore from a high availability point of view. So instead what I'm going to do is maybe send an HTTP GET and figure out, did I actually get the web page response back in? If I don't get the response, I'm going to take that server out of the virtual pool, so they're no longer able to forward traffic for that particular server pool that I've defined. So in the larger scope of things, this is going to be a much smaller portion of the exam.
And Cisco did also note that they're not going to have their global load balancer as well. So we just had, the sites select the GSS, global site selector. They are just going to have the ACE load balancer for a single site. So we don't have to worry about doing the global site selector between data centers. In fact, I would imagine if they're going to have us do other data centers, which they probably would with OTV, they may or may not, but I don't think they'll have you have actual servers over there that we're going to be doing vMotion or things like that. This isn't a VMware exam. It's not, it's not. So anyhow.
So it definitely fits into the overall design here. And as you can see, I mean, only spending this 45 minutes, hour or so that we talked about it so far, the scope is very, very large for these topics. So this brings us to then, how are we actually going to split this up, and how are we actually going to deliver this in the scope of training? Specifically, we're going to have 4 different delivery methods for the data center training. Okay, first and foremost is going to be the live classes. So there's going to be online classes. There's also going to be live on-site classes. Next is going to be the video series, both in streaming formats and in download formats, similar to the other content that we have up to this point. Another important feature of this is that it has cross-platform support and it's DRM free. So you download the video, put it on your iPad, put it on your Android phone, put it on your Windows phone, that's up to you. Okay, we want to make sure that you as the learner, you as the engineer, have flexible access to this content to use it whenever, however you want. That's up to you.
Yeah, we ask you not to share it, but the truth is that DRM just becomes prohibited. It becomes prohibitive to the valid person that paid for it and wants to learn.
End up punishing the paying customer.
Exactly. And we don't like to do that.
So all the material will be available in either the streaming format or download format. We will also have self-paced lab material, like workbook type labs, and then also rack rentals. Okay, the last one is going to be kind of tricky because, as you guys know, this hardware is basically the cutting edge hardware that's out there right now, where we're talking about 100 gig E-line cards that are literally millions of dollars. So we're going to have to come up with some creative solutions. We're going to talk about this in a little bit more detail shortly. But we will have availability for equipment. You will be able to come in and get access to Nexus 7K, Nexus 5K, 2K, UCS, Nexus 1000V. So basically all the platforms that are within the scope of the exam, we will be offering access to those platforms to you guys, the customers.
And there may be others that we're unaware of, but we haven't found anyone else that's offering that yet. Right. So we're pretty excited and proud to be able to offer these rack rentals to you.
So the first of these, the classes, there's going to be 3 boot camps to start based on these 3 topic domains that we talked about. And these are coming within the next few weeks. So at the end of August, we're going to be running the Nexus boot camp. It's going to be an online class, basically same exact format as Mark and I are running this. We're going to be doing this Nexus class together. Then at the end of September, I'm going to be doing the storage class as an online class. At the end of October, Mark is going to be doing the UCS class. And most likely, we're probably going to be stopping in back and forth to each other's classes and, giving our own individual takes on the topics. But the key is that these 3, you can attend them live online, or they're going to be available as either downloadable videos or streaming videos following the end of the classes. So figure right at the beginning of September, which is coming up pretty soon here, you'll have access to the first portion, which is going to be the Nexus class, then the storage and the computing. But the big key point about these classes is that these ones are going to be specifically the CCIE level classes. So there's a further division that we're going to be doing that goes beyond just these three to make sure that everyone has the fundamental knowledge of the additional topics. And the way that we're doing this is that there's going to be additional video series that we're breaking down into three further parts, which are going to be the primer series, the deep dives, and the troubleshooting series. Now, what this is going to allow us to do is to take a topic like, let's say, fiber channel. Okay, you need to understand fiber channel before you can understand fiber channel over Ethernet or FCIP. It doesn't make sense to, to focus just on that very top portion, maybe 2% of what's going on in just CCIE Data Center storage before you really understand what storage is.
You might be able to configure fiber channel over Ethernet without knowing fiber channel,
right.
But should you?
Right. Because at the end of the day, the reason you're learning this is so you can actually apply this in the real world.
Yeah, we want you to pass the exam, but first we want you to be an expert.
Exactly, exactly. And that's really the key, our philosophy for all of the tracks, is that we're not going to prepare you for the exam. We're going to make you an expert engineer. As a byproduct of being an expert engineer, you will pass the exam. But the problem is you can't go at the opposite direction. You can't prepare for the lab and as a byproduct of that learn the technology. You have to first learn the technology, make sure that you have a very solid foundational base, and then you can look at how do I actually implement this in the scope of the lab exam, what are like the bad designs that they're going to ask me, and then for me to work backwards to solve. I would hate to see someone that looks at the data center lab as a real world design and then actually tries to go to implement that. Because for those of you that have been to like routing and switching lab, security, voice, service provider, it's not real world design.
Yeah, that's never been the intent of the IE. IE has been how to do it and can we implement it and can we work around obstacles. The DE is more about design.
Right.
And they could probably introduce a CCDE exam for data center. There's enough material, whether they will or not.
Exactly, yeah. So the key of these three series, these are going to be self-paced video series, and they're not only going to apply to CCIE Data Center, it's also going to apply to any everyday engineer that just wants to learn these particular topics. The key here is that it's going to be very granular in its delivery. So if you want to learn how virtual port channels work, you can get just the videos on virtual port channels. If you want to learn just how OTV works, you can get those particular videos. Okay, if I have a project coming up in 6 weeks and I have to implement ACE, I want to learn ACE. I don't want to learn, storage networking for a CCIE data center. So it's going to be a very modular approach that at the end of the day, it's going to give you guys, the end customers, more flexibility as to really how do you solve your individual learning goals of what you're trying to accomplish here.
And we won't just be creating them in a modular fashion, but we'll also be releasing them in a modular fashion. So they'll come to you as we finish one particular topic, which will get it out to you much quicker. It just might not be that to begin with every topic is covered, but by the end, certainly every topic will be covered.
Right. So specifically with delivery of this, it's going to be towards the end of this year, starting Q3. So we may get some of these, like let's say Nexus, to start within the next couple of weeks, starting to trickle out there. Like if you're an All Access Pass member, you'll already get access to these. So as the videos start to be released, then you'll be able to take them individually. The next portion is then going to be the self-paced labs. So we're going to be subdividing these further as well to make them more modular. Because like I said, you may not be going for CCIE Data Center. You may just want to learn how do I configure virtual port channels on Nexus and do a lab on it, exactly. Or how do I configure OTV. So the labs are going to be broken down into what we would consider primer labs. It's like the basic fundamentals. How do I configure EIGRP routing on Nexus? Okay, I know EIGRP, but I don't know Nexus syntax. So I want to see what's the iOS config, what's the NXOS config, and how do they compare? What are the differences in show commands? What are the differences in debug commands? I
know the first time I logged on to a Nexus, however many months ago or years ago that was, I couldn't get EIGRP running because I didn't enable the feature. Exactly. It's something as small as that you might need to know. Well, you will need to know. Right. Yeah. And these primer labs are going to address those basics.
Right. Then the next ones would be the deep dive labs, which are going to get more into the advanced designs of like virtual port channels or fabric path or any of the individual topics. Then finally culminating in the full scale CCIE labs that would simulate like your actual 8-hour lab exam where you have this full overall topology, and then you're in charge of building this. So not only is it going to be Nexus switching, but it's also going to be computing, it's also going to be storage networking, it's going to be application switching, Nexus virtualization. So a lot of the individual components is going to be very, very large once you start to build this together. But the key with the labs is, just like the video series, it's not only going to apply to you taking the CCIE lab exam, it's for any everyday engineer that just wants to learn how the topics work. Because I may be able to read the documentation on what is VPC and look at the syntax, but unless I actually get on the command line and see it working for myself, then I'm not really going to feel comfortable actually implementing that in the real world.
By the time you've taken the primer, the deep dive, and the full series labs, you will be taking those CCIE level labs. So it will certainly apply to that, but just not only to that.
Exactly, exactly. The next portion then is going to be the rack rentals. So just like the videos and the self-paced labs, these are going to be subdivided further to make the topologies more modular and more flexible. So for example, you'll be able to rent just Nexus 5K and 2K if you want to play around with things like virtual port channels or configuration synchronization between them. These will be things like the 5548 unified port platform, which again allows you to run LAN and SAN at the same time. So I could have 1 gig E, 10 gig E, 2 gig fiber channel, 4 gig fiber channel, etc., running on the same platform. And then also the fabric extenders, the 2232, which also technically you could pair those with the 7K. So you could do like a 7K and 2K lab or a 5K and 2K lab. So there'll be different variations that we'll have access to.
And this is for a couple reasons. We want to make them modular. One is to limit ADD people so that they can actually focus on the hardware that they want, people like me, to the, to the particular platforms that I need to do this smaller lab or this smaller, primer or deep dive lab, but then also to make it much more cost affordable. We wanted to find a way to be able to bring it to you. This hardware, a 7K is just one, is not cheap. We have multiple. We're going to have many of these. So in order to be able to bring them to you at a cost affordable level, we wanted to break them down into much more modular rack rentals as well.
So like Mark was saying, it's not only going to be Nexus 5K, Nexus 2K, Nexus 7K is going to be in there as well. The key with this is that it includes both the M1 modules and the F1 modules. And there is a key difference between them. The M1 modules would be your upstream facing links that go towards the IP network. So these are the ones that allow you to do the layer 3 routing features. So on an M1 module, without this, you wouldn't be able to do EIGRP routing, OSPF routing, BGP, OTV. Anything that is a layer 3 feature, you need this physical card in order to actually do that. Okay, at the same time, with the F1 module, which you could consider this, remember this one is related to fabric path for F. The M1 is like your multi-layer module, that's the layer 3. So you really have to have both of these to get the overall view of how does the platform fit into different designs. Where the F1 module is very high performance, layer 2 only switching. The M1 module is not as high performance as F1 because it's a feature module.
Yeah, it's
where you would
much more rich features.
Exactly,
except
exactly.
for fabric path, which you have to have the F1.
We'd have to have the F1 as well.
And that's why Cisco lists both on their
Exactly,
exam.
exactly. And also these are going to be 10 gig E cards, so as you can imagine, 10 gig E port, not cheap.
Right. And we're not going to probably have, someone asked a question about the M2 and the F2, the second generation, as well as the SOUP 2. We haven't decided on the SOUP 2, but the point is that we'll have at least the version 1, which will be able to run most, if not all, the features. And again, we're trying to bring them to you in a cost-affordable way. Right. So at some point down the road, maybe years from now, we might upgrade and add newer cards if newer features require those newer cards. But for now, we can test everything that we want to test on the generation 1 cards. And
you'll see once we get into the hardware things, and this will be like part of the primer class, that if you're going to implement Nexus, you really need to understand what is the hardware architecture first. Yes. What are the differences in the modules? What module can run what feature? What module cannot run what feature? Because you don't want to order a Nexus, get it into your data center, and then you realize you can't even use it for your design because you bought the wrong stuff. So this is part of what we're going to be talking about is the hardware architecture. what are the differences in the modules, and then specifically what features can you run, which features can you not run. But the way that we have it set up with the SOUP 1s, the 10 gig E F1s, and the 10 gig E M1s, you should be able to run every feature that's within the scope of the exam, and 99% of the scope of features that anyone would actually be deploying. We'll also have access to the UCS chassis and the Nexus 1000V, because as we were talking about, since the 1000V runs as a virtual machine, you can't do this unless you have a server to actually run it on.
And the UCS are perfect.
And the UCS, it's already there, so it's the perfect platform to run it on. Right. This could be with the B server blade chassis, or it could be with the C servers, the C series, which is like your standalone, like 1U, 2U server that, in traditional server design. So we'll have access to both of those, the UCS blades, the UCS manager, the C series standalone devices. Also storage for the MDS. We'll see that there's a number of different designs that you can accomplish with the Nexus hardware. You theoretically could take the MDS out of the design completely if you were to use like the newest specification, like to only use FCOE, or maybe only use iSCSI or something, and just use layer 3 routing, or use the unified ports. But this does still, it is still an important point of the vast majority of designs now.
And there are still a lot of data centers out there that are running them, and they have not yet collapsed them into the unified fabric. So they may still be coming out of the server and converged network adapter in that sense, unified fabric, or maybe they're running like the UCS, which actually does take its converged network adapter and run out to the FIs, the fabric interconnects, over FCOE, but then presents a fiber channel port up to an MDS or something like this. Right. Because it's still largely deployed, as well as many other SAN switches like Brocade and things like that in data centers. It is included in the exam and in terms of the hardware that Cisco put on the blueprint, and it's very important to understand as well. Right. The syntax is very different.
Syntax is different. One thing that you'll see that is nice, though, is that the newer versions of MDS do run the code that some of the Nexus does. So the core syntax is going to be the same, like the logic of show commands, logic of config T, stuff like that. But since it did come from a different code base, it came from SAN OS. When you're first learning this coming from iOS or coming from Catalyst iOS, there is going to be a learning curve for it. And that's part of what the primer series is going to help with. That, I know EHRP, I know OSPF, I know BGP. I don't need to sit there and listen to you lecture me on BGP for 8 hours. Right. Okay, I want to know what's the syntax of BGP on NXOS. How do I configure it? What are the show commands? What are the debug commands? And that's more what we're going to be focusing on with these primer series that, probably up to this point, you already know a lot of the fundamentals. We just need to know how do we port it to the new syntax. Now, on the flip side, if you don't know BGP, then you have to learn that first. You can't, you can't implement OTV, or you can't implement Fabric Path without understanding how layer 3 routing works, how layer 2 switching works. So, and actually, we forgot to mention that kind of a prerequisite for this. Yeah. You really would have to have at least a CCNP level, a CCNP routing and switching level of knowledge in order to apply any of these topics. Ideally, you would have a CCIE routing and switching level of knowledge, because then, the layer 2 switching, the layer 3 routing, that stuff is going to be secondary. That's going to be easy. But as we'll see, once we get at least a very solid CCNP level of knowledge, I would say. So we're not going to be going into, with these classes, what is OSPF, what is, what is spanning tree, that type of stuff.
Before we move on with the rack rentals, there was a question about workbooks. And I just want to address this. I addressed it on the chat, but we're simply moving to a much more modular approach and also naming conventions. So in the traditional sense of what INE has released of workbooks, you're going to get that in our self-paced labs, but they're going to be broken down into very bite-sized chunks, very usable, more modular chunks, such as the primer-based, the deep dive-based, and then the full-scale, and then even additionally the troubleshooting. Right. So it will entail everything that the workbook had. I don't want you to think we don't have these, but we're not going to call it a workbook and just release one. Right. We found that that's an okay method. It's worked well, but having them in a much more modular approach, a much more modular delivery method, will not only give you more flexibility to study specifically what you want or need at any given time, but then us the ability to release them more modularly, but design them very focused on one technology. And then, of course, the full-scale labs will have everything overlaid in a very complex, convoluted, well, hopefully not too convoluted. Well, it might seem that way, but it's your job to decipher how to do that. And you will have already been through the primer and the deep dive and the troubleshooting, so it won't be convoluted at that point. It will be a full-scale lab.
So one way you could think about it, at the end of the day, it would still be a workbook, but we're moving towards more of a model of a technology library.
Right.
That you may not be studying for CCIE routing and switching, but you may need to implement BGP.
Right.
Or you may not be studying for CCIE security, but you need to implement ASA. So instead of dropping off a book of 5,000 pages of ASA configs, I want to know how do I do failover.
Having to dig through them to find that one little
Exactly.
piece. Right.
So going forward, you'll see that the release method that we're going to be coming out with shortly is going to be more modular. Most likely, this is going to start with data center and then kind of bleed back into the other tracks that we have, like routing and switching, security, voice service provider, those. But since we get to start fresh with data center, we can do it the right way to start.
Right.
It's very modular to begin with, and it's going to make it from our, like Mark said, the release schedule, which has always been a sticking point because it's very, very time consuming to produce this content.
We think it's going to really make for a much better customer satisfaction level. We think that you're going to, all in all, get a better product, get a better release schedule, as Brian said. We think that you're going to be much more satisfied with this particular approach.
Right.
So continuing with the rack rentals, so we have Nexus 2K, 5K, 7K, the UCS chassis, which means that Nexus 1000V would be on there. The storage platforms, which is going to include the actual storage switches, but then also the storage arrays, because without disks, really storage doesn't mean anything.
Yeah.
Then the application switching with the ACE. So the appliance, but then you actually need servers to test this out. So this may be like a server on the UCS chassis, or maybe this is just a standalone virtual machine or a standalone physical machine, but you need some box actually to test the end result of this.
Right.
So as Mark was talking about before, one of the things, let's say like Nexus TrustSec, for example. In the lab exam, they don't say that there's going to be ACS or that there's going to be ISE.
Right.
But from a practical implementation point of view, you can't understand TrustSec unless you figure out how does it actually integrate with the overall design.
It's difficult to authenticate radius without a radius.
Without a radius server, exactly. So going along with this more modular approach to the labs and to the videos, we are going to be taking pieces of technology that are outside the scope of the exam, but are inside the scope of practical implementation. So if you want to learn TrustSec, you're going to have to learn that within the scope of having an ACS server. Or, if I want to learn ACE, I need to make sure that I actually have physical servers in order to actually test the end result of that. So the key here is that the way that we're going to be designing the rack rentals is that the topologies are going to be very flexible, where you could rent an individual portion of it. You will also have the availability to rent the entire type of topology. Something like indicative of this diagram.
It will cost more.
As you can imagine, though, it will cost more to rent because at the end of the day, the equipment is very, very expensive for these particular platforms. Like in the case of F1 M1 line card, we're talking $30,000, $40,000 a line card. Yeah. Not to take into account the optics, the fibers, and everything.
The fabric
modules. Yeah. So it really starts to add up when you piece these platforms together, and that's really the key of why we need to make the rack rentals as modular and flexible as possible, because you're not going to need the whole topology until you're at the very, very last step of your preparation. So by that time, you should already know, how do I configure VPCs? How do I configure OTV? How do I configure the service profiles on the UCS? How do I configure the server load balancing config on the ACE? So you need to know these things individually before you can piece them together in the final overall design. The last portion of this then is going to be the additional live classes. So as we mentioned, within the next 2 to 3 months or so, we're going to be having the the online Nexus class, the online storage class, and then the online computing class, the UCS
So it's really the last
class.
week of each upcoming
Last
month.
week of each upcoming month, exactly.
Consecutively.
Going forward beyond that, we are going to be doing live online and live on-site. So like in our physical classroom here, classes that are specifically on Nexus, so things like Nexus 2K and 5K, Nexus 7K classes, then things on like UCS, how does the Blade server chassis work, how does the C server work, how does Nexus 1000V work, how does the UCS-M work, because you may not, like I said, be going for CCIE Data Center. You may need to know, how do I deploy UCS now, because I have a project coming up in 2 weeks for it. So making not only the self-paced videos modular, but also making the live classes more modular, that's going to give you more flexibility to choose the individual topics that are relative to you or that are relevant to you.
Some of the reasons that people tend to tell us that they want these live on-site, online sometimes certainly as well, but online maybe if they can't afford a travel budget or something like that, but on-site because they want hands-on access to the instructor.
Right.
They also want hands-on access to the equipment,
Yeah.
and they want us to maybe even come to whether their city or at least their general geographic area. And we haven't exactly nailed down the exact cities yet, but we'll probably be coming to, I would imagine, London, certainly Seattle, some of the various, east, west coast, and probably over somewhere in Europe that we'll bring it occasionally as well.
Because at the end of the day, everyone has different learning patterns. Some people learn better reading books, some people learn better taking online classes or watching videos or taking live classes.
Some people have to be sequestered to a live class to get away from the wife and kids for a week.
So depending on whatever works best for you, we're going to have those different options available. Like we talked about, live online classes, live on-site classes, recorded videos, self-paced labs, and the rack rentals as well,
correct.
the equipment. Lastly, moving forward beyond this, outside, go ahead.
The schedule for those
The
classes.
schedule is going to be starting Q1 of 2013. So within the next week or so, those classes are going to start to pop up on the schedule. Then first delivery for them is going to be at right around the first of the year or so,
that's correct.
January or so. So moving forward beyond this, outside the scope of CCIE Data Center and Cisco Data Center in general, in the real world, everyone knows there's no such thing as a Cisco-only network or a Cisco-only data center. There's lots of individual pieces that go into today's networks. And a lot of companies, for the sake of compliance, they're not allowed to buy equipment just from one vendor. That I have to have, servers from Dell, from IBM, from, XYZ vendors, because I don't want to put all my eggs in one basket. Okay, the same is true with data centers out there. You're not going to go into a data center and see only this specific design and no other equipment beyond that.
Right.
So going beyond this from a practical...
Plus Cisco doesn't make the discs.
Plus Cisco does not make the discs.
Yet.
Is it? Yet.
Yet.
Yes. But they do make the actual racks, cages.
That's
yes.
true. They do.
So going beyond this, we are going to be moving into additional technology and additional vendor training for lots of different topic scopes, for things like VMware, Xen, OpenStack, different types of virtualization from the actual end host point of view, different types of storage implementations like big vendors like EMC, NetApp, also open source solutions like OpenFiler that you could run on the servers that you already have. Then different types of layer 2 switching and layer 3 routing vendors like F5, the Brocade Arista switching, Juniper, both from a layer 2, from a layer 3, and from a security point of view. So a lot of these different vendors we're going to be adding into the mix. The key, though, is that this delivery is not going to be as certification-centric as the Cisco training is, because you may not need to get Juniper certified or VMware certified, but from your day-to-day job, you may need to know, how do I use JunoS, or how do I use vSphere or vCenter? So the key for this is that we're basically going to be building what's a multi-vendor technology library that's going to follow along with this same type of structure that we have primer videos, primer labs, equipment that you would be able to get access to, but from a larger view of really what someone would need to implement on their day-to-day basis.
And we're doing this because we've been asked to do this. People know the INE name and trust the INE name, and they know that the level of quality that they're going to get from this training, whether certification based or whether just, many people come to us and do the training maybe in another platform, or another discipline or track. Maybe they did a CCIE routing and switching, and now they want to know about wireless. They're not even necessarily going for a wireless CCNA or a voice CCNP, but they know that they can trust the training, they know that they can trust the quality of delivery, so this is why when we've been asked to do this, we're introducing this into our training portfolio.
Now, what's nice about the Cisco stuff, though, is that their real-world implementation does pretty well follow along with their certification tracks.
Right.
So if you want to learn Cisco routing and switching and you go through CCNA or CCNP, you inherently will learn Cisco routing and switching. But for some of the other vendors, it's not as clear-cut as that. So, I know layer 2, layer 3 networking. We just placed an order for 1,000 Arista switches. I don't need to know what is Ethernet, what is spanning tree. I need to know what is their syntax, how does it different from what I've done in the past, what are the
standard, it's open.
Exactly.
Knows it. Right.
So that's the key going forward with a lot of these new vendors and a lot of the new technologies. That in the real world, it's not the very small Cisco view where the vast majority of the equipment probably is out there. Cisco-based, and a lot of these designs are based on like Cisco designs, but there is still a large focus of other vendors and interoperability between the technologies. We'd like to thank everyone for coming out today. We have a lot of new exciting things going on here at INE going forward, and we would like to get you involved with that. So any questions you have now, feel free to talk to us, or any time after class. So just send either of us an email if you have any questions about this. There is also a section on the online community that is dedicated now to CCIE Data Center, the technical topics and the general discussion. So if you have questions on, like, let's say hardware or anything like that, you're better off posting them there so that when we answer, everyone from the community can benefit from those answers.